Hello, good afternoon to all my panel. My name is Arish Amir Iman bin Azlan from class 4B. Today I will presenting to you my final year project slideshow. My title is about experimental validation of multi-layer cylindrical micro-perforated panel for broadband sound attenuation. For self-introduce, my name is Arish Amir Iman bin Azlan again. My ID student is 2024631218 from class 4B. My supervisor name is Dr. E. Muhammad Izzuddin Alisa. So for this slide, I will be go through the problem statement as what I've been researched recently for my thesis, and this slide. First point is straight microperforated panel have limited sound absorption performance. They may absorb sound efficiently when sound waves come from a specific direction or single angle, but their performance decreases when noise arrives from multiple angles or various directions. So the efficiency of straight microperforated panels performance will be decreased or less efficient. Second, single layer straight microperforated panel are ineffective for broadband noise. They only provide good absorption within a narrow frequency range, but they cannot efficiently reduce noise over a wide range of frequencies or broadband sound attenuation. Third, environment with multidirectional noise require better solution. As we know, our place such as industrial areas, train stations and ducts have noise coming from various directions or multiple angles. So that conventional straight MPPs or microperforated panel may not provide sufficient noise attenuation in this environment. As what I've been talk about my first point, the straight MPPs become more or less efficiency when it comes to multiple angle. Fourth, need to investigate cylindrical microperforated panel. Cylindrical microperforated panel may improve sound diffusion and absorption across a wider frequency range due to their curved surface. However, their acoustic performance of needs to be evaluated and compared with this microperforated panel. In conclusion, for my problem statement, well, why I choose cylindrical shape, it is because their curved surface can absorb more wide range of frequency better than straight microperforated panel. So the efficiency will be increased more than straight microperforated panel. Now, for this slide, I will go through my objective for this project. Firstly, to fabricate and set up multi-layer cylindrical microperforated panel samples for testing. The fabrication process involves designing the cylindrical panel with selected key parameters such as hole diameter, air cavity depth, and the number of layers, also the perforation ratio. In this project, three layers of cylindrical microperforated panel are used to improve sound absorption performance. After fabrication, the samples are assembled and prepared for experimental testing. Second, to evaluate the broadband sound attenuation performance through experimental measure. The fabricated cylindrical microperforated panel samples are tested to determine their ability to absorb sound over a wide frequency range. Experimental data are collected and analyzed to evaluate the effectiveness of the multi-layer design and to identify the influence of the selected parameters on sound attenuation performance. Now, I will talk about my scope of work for this project. Firstly, design of three-layer cylindrical microperforated panel or CMPP. I will design my cylindrical microperforated panel using AutoCAD software or SolidWorks, and then develop a cylindrical structure consisting of three microperforated panel. Second, investigation of hole diameter. After I've been research for my thesis, study the effect of different micro hole diameter on sound absorption performance. and then determine the influence of hole diameter on acoustic resistance and absorption efficiency. So after the investigation made, I will choose the perfect hole diameter uh, to use in my cylindrical micro-perforated panel project. Third, investigation of perforation ratio. Firstly, analyze the effect of perforation ratio on the sound absorption coefficient. Identify an appropriate perforation ratio to improve acoustic performance. This investigation will be made from comparison from other researcher such as Ma or my first supervisor from single layers MPP and cascaded, so that I will choose the perfect perforation ratio to use in my project. Fourth, investigation of panel thickness. Determine the relationship between thickness and frequency absorption range. Evaluate the influence of panel thickness on resonance frequency and sound absorption characteristic. Five, investigation of cavity depth or air gap between each layer. Study the effect of cavity depth on low frequency sound absorption. Determine the optimal cavity depth for improved acoustic performance. This one of the important key parameter when I do my research, because this parameter will be determined such as uh, efficiency of sound absorption. So I will choose the perfect one. Six, implementation of three layers cylindrical microperforated structure. Apply a three layers cylindrical microperforated panel configuration to achieve multiple resonant frequencies. Evaluate its effectiveness in broadening the sound absorption bandwidth. For my final year project, I will use three layer cylindrical microperforated panel. Uh, this is because I want to achieve better absorption for multiple resonant frequencies, better than single microperforated panel or cascaded microperforated panel. 7. Fabrication using PLA material and 3D printing. Manufacture the cylindrical microperforated panel using PLA filament. Utilize 3D printing technology to produce accurate microperforation and cylindrical structure. So my final project, I will create my cylindrical microperforated using 3D printing and using PLA filament material. 8. Acoustic performance testing and analysis. I will conduct sound absorption tests on the fabricated cylindrical microperforated panel using impedance tube. Analyze the effect of design parameters on the acoustic performance of the panel. So, my scope of work for this project, I will investigate properly to find the right key parameter, and I will use that key parameter into my project, which is three layers cylindrical microperforated panel, and I hope I will achieve a better result, which from absorption sound better than single layer MPP or cascaded MPP. Now I will go through my chapter 2, which is literature review. I choose to present about acoustic noise control method. Noise control method divided into two, which is passive and active noise control. First, passive noise control or PNC is a method of reducing noise by using physical materials or structure to absorb, block, and isolate sound without requiring any electric power or external force or external power. Here are some comparison that I made from my thesis. Porous material, foam, and expansion chamber have limitation in the low frequencies and broadband noise control, whereas micro-perforated panel sound absorption over a wider frequency range without requiring thick porous materials. The comparison shows that micro-perforated panel provide more efficient when it comes to broadband frequency range than porous material, foam, and expansion chamber. So it's a good choice for to use micro-perforated panel in passive noise control. Second, active noise control. Active noise control ANC is a noise reduction technique that use electronic system to reduce unwanted sound or noise. It works by generating a sound wave with the same amplitude but opposite phase, 180-degree out of phase, to the unwanted noise. For example, as our earphone or wireless earphone, it has features named noise cancellation. That will include the active noise control. But the active noise control have limitation, such as less effective for high frequency noise, requires electronic component, more power supply and control system, and less more complex and effective, more complex and expensive than passive noise control methods. Even though, uh, e- even though our earbuds right now can have control systems such as noise cancellation, but when it comes to high frequency noise, uh, the absorption cannot be controlled anymore because it's too high to handle. So from acoustic noise control method, passive is the best answer to reduce sound or absorb sound. And I choose micro perforated panel. Here's some of the advantages. I give three. First, high sound absorption performance. It effectively absorbs sounds, especially when designed with suitable hole diameter, perforation ratio, and cavity depth, which is a perfect key parameter to do. Secondly, broadband sound absorption. Multi-layer or micro-perforated panel can absorb sound over a wider range of frequencies. Effective at low and mid frequencies. Properly designed micro-perforated panel can improve absorption in frequency range where traditional porous materials are less effective. So that from these advantages, I can say that micro-perforated panel have their own key parameter, so that when key parameter are perfectly used, micro-perforated panel will be perfectly achieve the sound absorption from a wider frequency. Now I will talk about my chapter 3, methodology. Here are some comparison I made for this presentation between single layer micro-perforated panel and cascaded micro-perforated panel. This comparison I made because to see between sound absorption bandwidth, resonance frequency, and broadband noise control, which one is the greatest result. For single layer micro-perforated panel, sound absorption bandwidth is narrow bandwidth, which is single angle. Resonance frequency, single resonance peak. Broadband noise control become less effective. As I thought, as I present to you in my problem statement, single layer may only effective when it comes to narrow bandwidth or single angle. When it comes to multiple angle of various frequency, the broadband noise control become less effective. For cascaded microperforated panel, sound absorption bandwidth is widest bandwidth among these three designs include multi-layer microperforated panel. Resonance frequency, multiple resonance peaks covering a broad frequency range, which is better than single layer microperforated panel and multi-layer microperforated panel. Broadband noise control is highly effective when the sound absorption bandwidth is wider and resonance frequency is covering a broadband frequency range, then the broadband noise control is highly effective to absorb. Now, for this slide, I will talk about multi-layer microperforated panel, which is my title final year project. Here are some advantages that I pointed out for my thesis. Firstly, it has wider sound absorption. Bandwidth absorbs sound over a broader range of frequencies compared to a single layer microperforated panel. When wide when wider sound absorption, it can absorb sound from multiple angles. Second, multiple resonance frequencies. Each layer creates different resonance frequencies, improving all acoustic performance. When it comes to multi-layer, each layer can absorb different frequencies, so it becomes more efficient than a single layer microperforated panel. Third, better low frequency absorption. It more effective at reducing low frequency noise than a single layer microperforated panel, as I told before. Fourth, improve broadband noise control, suitable for environment with noise covering a wide frequency spectrum. As I mentioned in my slide problem statement, our environment place such as industrial area or train station, the frequency comes from multiple angle. So single layer microperforated panel cannot absorb that frequency at all. It become less efficiency. So cascaded and multi-layer microperforated panel will absorb more effectively, highly effective. Five, fifth, reduce narrow band absorption limitation. Overcome the limited frequency absorption range of a single layer microperforated panel. This multi-layer microperforated panel has overcome the limited frequency that has in single layer microperforated panel. So my objective is barely achieved. Lastly is enhance acoustic performance. Multiple layer increase sound wave interaction and energy dissipation. For this slide, I will talk about my flow chart. So from the very first start, literature review uh, have some introduction about my project and also who invented this multi-layer uh, microperforated panel, and also have some key parameter, and the key point is I compare those three MPPs, which is single layer, multi-layer and cascaded MPPs. Literature review is written down in my chapter 2 thesis. So now I will go to my next step, which is find design for cylindrical microperforated panel. As I mentioned before, I will use AutoCAD or SolidWorks software to find my design for cylindrical microperforated panel. After I find my final design, the next step will be find suggested dimension for parameter. To find suggested dimension for parameter CMPPs, I used to research the other researcher such as Ma and Dr. Izzuddin Alisa. From their data analysis, I pick and I choose the great result for dimension for my parameter cylindrical microperforated panel, and then I do numerical simulation and prototype fabrication. For fabrication, I As I mentioned before, in my scope of work, I will create my product use 3D printing, and then after the product is created, the experiment testing will be test on impedance tube. If the test failed to achieve, I will go back to my final design and adjust some dimension for my parameters, and then run again the testing on my impedance tube. Once achieved, I will collect the data and put on my thesis. For this slide, I will talk about design and fabrication. As we can see, these are four key parameters that I mentioned before in my slide. Firstly, we have panel thickness, second, hole diameter, third, perforation ratio, and lastly, we have air cavity depth. Let's have a look for panel thickness. Panel thickness affect the acoustic resistance and resonance frequency of the MPP. A thinner panel generally provides higher resonance frequency, while a thicker panel can improve structural durability. So it means the thinner and the thicker have pros and cons in their main role. Second, we have hole diameter. Hole diameter is one of the most key parameter affecting sound absorption. Smaller hole increase acoustic resistance, allowing more sound energy to be dissipated and improving absorption performance. It says that smaller holes increase acoustic resistance better than bigger holes. Third, we have perforation ratio. The perforation ratio determines the percentage of open area on the panel surfaces. An appropriate perforation ratio helps optimize acoustic resistance and reactance, resulting in better sound absorption. And lastly, we have air cavity depth. The air cavity acts as resonance chamber behind the panel, increasing the cavity depth, lower the resonance frequency, improving low frequency sound absorption performance. And this my final year project, I chose to do multi-layer micro-perforated panel because each layer I can use different key parameter to absorb different frequency and different resonance to get a better result and create a good data analysis better than others. And lastly, for my conclusion, in conclusion, this project focuses on the development of a three-layer cylindrical microperforated panel for broadband sound attenuation. The study investigates the effect of the key parameters such as hole diameter, perforation ratio, and panel thickness, and also cavity depth on sound absorption performance. The use of multi-layer cylindrical structure is expected to provide wider frequency absorption and improve acoustic performance compared to conventional single-layer panels. So I hope for my final year project, I will create a good data from the others better than single layer and cascaded multi-layer micro-perforated panel. And it's the end of my presentation. That's all from me. Thank you to all my panels and also my supervisor.